Hi guys. Last time we learned about the law of sine. So as abbreviation, let me just put loss in here or LS. And it tells us that sine of A divided by A equals to sine of B divided by B and equals to sine of C divided by C. If you notice, because this one is a law of psi, so we only have psi functions in here, right? Like we're not allowed to have any other phi functions, such as like tangent, cotangent, secant, cosecant, or even cosine here, because it's law of psi, so it's strictly for sine, right? And also, if you notice on the top parts, we're gonna get all the angles. We're using uppercase because it's on the top part up, so it's like low uppercase for angles. And on the bottom parts, we're using lowercase, like lower, and then for lower part, and then for the lowercase letters, those are the size. Okay, so let me put this one out here. So the triangle, a regular common triangle in here, it doesn't have to be right triangle at all. It will look like angle A in here. Opposite to it, we have side A. Angle B in here. Opposite to it, we have side B. Angle C in here. And opposite to it, we have side C in here. And this side C in here, it doesn't have to be right angle, okay? Because we're talking about oblique triangle, which is like any common regular triangle that you can have. It doesn't have to be right triangle. Okay, so in the quiz 4, I saw a lot of you guys assume that C in here is right angle. It's not like that. If the problem doesn't give you C as a right angle, it doesn't have to be right angle. Okay, it can take on any measure. It can be acute angle. It can be also obtuse angle. It can be anything. Okay. And for a lot of size in here, we learned 3 applications to it. The first 2 easy applications to them are the case of SAA. I'm not sure why I cannot write this. This glitches. It's weird. Let me start over. Okay. The first 2 cases we have SAA for side angle angle. And another easy case, we also had a SA for angle side angle. And the last case is harder a little bit, so let me just put it in red. Is SSA. Why do I say it's harder than the other 2 cases? Because for the last case in here, you never know if you have no solution, 1 solution, or 2 solutions. After you getting the work done, the only way that you know is that you have to double check on the 2 scenarios. So you always assume that there are 2 triangles. Okay, and I told you guys there's a way to do it, but I don't want you guys to memorize it because you have a lot to memorize in this class already, right? So the way to do this problem is that you first find the easier angle, and if you don't recall it, please review back on 9.2 on what I mean by easier angle. And after that, make sure you find a supplementary angle of that easy angle. So how can you find a supplementary of an angle, right? Like we're gonna do 180 minus whatever angle after we get it. Make sure you don't confuse between the supplementary angle of an angle and the missing angle of the triangle, okay? So just to confirm in here, A is not the supplementary angle of C. A1 is a supplementary angle of A2 because A1 plus A2 equals to 180, okay? If you notice, A plus C does not equal to 180 because in a triangle we have ABC, right? So that means that angle A plus angle B plus angle C equals to 180. A plus C, it doesn't equal to 180 at all, never. Okay, so make sure you don't get confused over that. But if you do, please email me, contact me to get more help. Okay. So a recap for law of psi is that make sure you remember the 3 cases in here. And make sure that you always have 1 pair to start up with law of psi, okay? What I mean by 1 pair in here, you have to have either 1 pair of angle and psi. So you have you either have the pair of angle A's and psi A, or the pair of B's and or the pair of C's, okay? It depends on the question. It depends on the problem. You will know it when you get to do it, okay? And let's talk about today's topic. We're going to have law of cosine here. So as you can see, right off the bat, we have 2 applications for law of cosine, which is SAS and SSS. So for now, we have 5 cases, right? 3 for law of psi and then 2 more for law of cosines. Make sure you know which case is for which. Why? Because on the test, on the quiz, like we don't have any quiz anymore, but on exam 2 and on the final, I'm gonna ask you guys some question like, can we apply the law of psi to solve for the case of, I don't know, like AAA or like SSS or something like that. Make sure you know that SSS is only the application for law of cosine, not the application for law of psi. Okay, so don't trip over the names in there. Make sure you can tell the difference between the 5 cases, and make sure you know which law is used for which cases. Okay. So a little bit reviewing here. So we talk about oblique triangle. Oblique triangle, technically it means no triangle, no right triangle, okay? So as long as you don't have a right triangle, we call it an oblique triangle, okay? And the labeling system in here, just as before, opposite to A, we have letter A, opposite to B, we have letter B, and opposite to C, we have letter C. And again, we use uppercases. We use uppercase for all the angles and lowercase for all the sides in here. So make sure you don't get confused between uppercase and lowercase letter, okay? And here's a quick description of what I just said. So if you want, you can read it. And then if my description confused you, please email me and ask me for more clarification, okay? And just like what we did in 9.2, to solve for an oblique triangle in here, it means that we have to get all 6 data, including the 3 sides and the 3 angles, okay? So chances are the problem will give you 3 data among the 6, and we have to find the other 3 data, okay? You experience it with 9.2 already, so you should know what I'm talking about. But if I confuse you, please let me know, okay? You can contact me on GroupMe or email or just Zoom meeting, okay? And let's get into the first case of SAS. Or in general, let's talk about the law of cosines before we talk about its application, right? So what does the law of cosine tells us? It tells us that c squared equals to a squared plus b squared minus 2ab cosine of c. As you can see, we have 6 formulas in here for law of cosines. But let's divide into two cases in here. Whatever we have on the left hand side are used to solve for the side lengths, and whatever we have on the right hand side in here, the 3 formulas in here, are solved for the angles. Okay, so for the sides in here, it's quite easy to remember it. First of all, because we talk about the law of cosines, so we only allowed to use cosine function in here, right? We're not allowed to use sine, tangent, cotangent, secant, or cosecant in here. It's all about cosine. Okay, and if you want to find the little c in here, you're going to do a squared plus b squared first. And after that, to balance out the equation, to balance out a number in here, we're going to have to minus it. And since we have 2 sides from the right side in here, a and b, that's why we have the 2 in here. And we did addition already. That's why we do product in here. We multiply them. And from there we couldn't stop because, well, we cannot stop, right? Because this is the law of cosine and we haven't talked about cosine yet. So make sure you attach cosine up the angle at the end. And the takeaway in here, the trick in here to memorize is that if you're looking for side C, you have to end up with angle C. If you're looking for side B, you have to end up with angle B. If you're looking for side A, you have to end up with angle A. Okay. And to talk more about the formula in here, it looks similar to the Pythagorean theorem, but rather than the hypotenuse, which is the only thing that apply for the Pythagorean theorem, in here you notice we don't have any minuses between the sum of the square in here. So everything in here is all sums, right? It's all pluses in here. It's a modifying version of the Pythagorean theorem. That's why we also have subtract things out from the sum of the squares to make sure the numbers balance out. That's how it's work. If you want to know the proof of the law of cosines, you can look it up on Wikipedia or on YouTube or anything that you want to. But the proof is long and hard, complicated to understand. That's why I don't prove it in here. I don't want you guys to remember the whole derivation behind this thing. But I really hope that you guys remember the formula. Okay, if you remember the first formula in here, the other 2 are just mimic it. And the formulas that we have on the right hand side in here, they coming from the formula we have on the left hand side. If you notice, for each of the formula that we have on the left hand side, if we solve for the cosine angle, we will have the formula on the right hand side. Okay, so that's not a big deal. And if you want to like remember it, say like cosine of c in here, it equals to like Pythagorean in here because we talk about big C in here. So we have to start with A and B, like the whatever is not mentioned from like the asking part in here. So if this is C, we will end up with C in here. And we will have A squared in here, B squared in here, and on the bottom, because we have like A and B, which is not like asking from a problem, then we will have AB in here, and because there are two of them, we will have the 2 in here. Okay? To me, it just comes like really naturally. Like I find it's easy to remember it. For some weird reason, law of cosine like sticked out to me more than law of sines, right? So I hope like it makes some sense for you guys. But you guys don't have to follow my like memorization technique in here. Try to look it up for another like memorizing technique if you want to. You can create your own mnemonics if you want to memorize it. So do whatever you have to. Make sure you memorize the formulas, because it's going to come in really handy when you need to apply it, when you need to use it during the test or during the final exam, okay? So for law of cosines in here, we're going to have 2 scenarios. The first scenario is in here. Let me talk you guys through the case of SAS. So for the first case in here, let me give you, like, what if the problem gives us little c, little b, and big A, and asking us to solve for the other 3 data, which is big C, big B, big C, and little a. How can we do it, right? So right off the bat in here, the majority that we know in here are the sides, right? So that means we have to look for the missing side first. How can I look for the sides? Well, I have like 3 formulas for the side on the left-hand side in here. And in here, I'm looking for A specifically, so I'm going to go ahead and using the last formula in here. So as you can see, I copy and paste the formula down in here. But make sure that this is A squared. This is not A, right? So make sure you like plug in a number and do all the crazy thing, like on the crazy formula or algebra for the right side. You will have to take the square root of it at the end to get your A. Don't stop there. Make sure you don't stop there and call it an answer, because it's not A. This is A squared, okay? We're going to talk about more in detail like when we get to the problems in the examples, okay? But just a heads up, this is only A squared. This is not A. So make sure you have to do the square at the end, okay? And because we know side angle and angle, that's why we call it the case of SAS, side angle psi, okay? And another scenario that we can have is that they can give us something like little a, little c, little b, like all 3 sides in here. That's why we call it the case of side, SSS. And we have to figure out the data, like the missing the 3 missing angles in here. We have to figure out the measure of the big A, big B, and big C. How can we do that? So we have the tools for the angle, the 3 formulas on the right side in here. Personally, I would go for the alphabetical order. So I'm going to go to solve for angle A first. And that means we're going to go ahead and apply the last formula in here. We plug in a number. And remember, this whole thing on the right side in here, it only equals to cosine of A, right? So make sure you would do cosine inverse at the end. Okay? Because this is not like your angle A. This is the cosine value of your angle A. So the takeaway from this one is that make sure you do the square root at the end for this problem or this case of SAS, and make sure you do the cosine inverse for this case at the end, else you're going to get the wrong answer because it's not like the desired result that you're looking for. Okay? And another takeaway from this one is that make sure you know the 3 cases that are applied for the law of size. For the law of cosine specifically, we know that we can apply the law of cosine for the 2 cases of SAS and SSS. So don't mix it up, don't mess it up for the 5 cases. Make sure you know which case is used for which laws, okay? And let's talk about the first example. Let's talk about the first case when we have SAS, okay? So first of all, I want to show you guys some tips that like I have from my personal like experience in math. For SAS in here, you always have to go for the missing side first, because like I told you guys before, we know like 2 sides in here, like compared to 1 angle, 2 sides would be the majority. So that means we have to look for the side first, the missing side first, before we get to look for the missing angles, okay? And after that, if you want to solve for the missing angle in here, make sure you put your calculator in the degree mode. And make sure you also have to do cosine inverse, because whatever you get in there is only the cosine value of the angle. That's not your angle. So make sure you don't stop in there and box your answer, because that's not the answer at all. It's only give you the cosine value of your answer. Okay, so make sure you do the cosine inverse in here to figure out the angle that you're looking for. And make sure you put your calculator in degree mode. Make sure it's not gradient mode or like gradient or like the auto gradient or whatever mode in here. It has to be in degree mode, or else your answer will look completely different than what you're expecting. Okay. And another big tool in here, I'm going to put it in red because it's really powerful. Make sure you don't forget the triangle sum. So say if you know 2 angles out of 3 angles in a triangle, make sure you go ahead and apply the triangle sum in here. You have to take 180 minus the sum of the other 2 angles to get the missing angle. Don't just blindly apply the law of cosine to find the last missing angle. That's not worth it at all, okay? It will increase the chance of you making more mistake, and that's not worth it for your time and your effort, okay? So just keep in mind that you have the triangle sum to use for angles. Okay. All right, let's talk about the first scenario in here. Let's talk about the first problem in here where we have letter A being 3, letter C being 2. Whoops, sorry for that. Let me erase this one out. So we have letter C is 2, and we also know that the big B, the angle in here, is 92. And to solve for the triangle, that means that we have to look for big A, big C, and little b. Okay, so again, we have to find the missing side first. That's our first step. How can we find a missing side? We will go ahead and apply one of the 3 formulas on the left hand side, as we know for the law of cosines. And here specifically, we have to solve for b, so we're gonna use the middle formula in here. After that, we plug in a number, and make sure you take the square root in here, and then we're gonna get the first answer for our little b, the side b. After that, since we know that b in here equals to 3.7, now we have 2 more angles to find, right? We have to know big A and we have to know big C, okay? How can we find a missing angle? Well, we have all the 3 formulas from the right hand side of the law of cosines from before. And after that, and I told you guys I usually go by alphabetical order, so that's why I would refer to solve for angle A first. But if you want, you can solve for angle C first. The order really doesn't matter at all. So in here, we plug in the formula, we plug in all the numbers in here, and then we get a value. But make sure you don't stop at this value in here, because this value is only your cosine value. It's not angle A at all. Don't box the answer, because it's not even the answer, okay? What you need to do is that you have to do the cosine inverse of whatever value that you get from here. And then put it in the calculator. Make sure your calculator is in the degree mode. And after that, you get the answer for angle A, okay? All to the last step in here, we have one more missing angle, which is angle C. Don't just blindly apply the law of cosines to find the angle C. That's not worth it. Make sure you know that we have the triangle sum formula in here. So in order to find angle C, we just have to take 180 minus angle A and angle B. And after that, we get the angle, which is angle C in here. To make it formal, let's put all 3 answers into the box and then box them, and then we call it an answer, okay? And as for your turn, I have the little problem in here if you want to try it. If you did it already in the practice problem, but then you feel like you did something wrong and it doesn't make sense, you can do it right now. You can retry it at this moment, okay? And just let me know if you have like any question or any concern about the topic, okay? Moving on to the next case in here, we have the case of SSS, side, right? So right off the bat, make sure you put your calculator in degree mode, and a quick recall in here is that we always have the big tool as the triangle sum in here, just in case you need to find the last missing angle, okay? And in here, the problem gives us 3 sides in here. So we have A equals to 9, B equals to 7, and C equals to 10, right? And our job is to solve for the triangle. That means that we have to look for big A, big B, and big C, right? So we have all the sides in here already. So that means that we have to look for all the angles. And I told you guys my reference would be the alphabetical order. So of course you can have it like in any way that you want to. You can solve for B first. You can solve for C first. Or like in any order that you want to, but the point is that you should get the same answers. Okay, so if you want, you can go ahead and try this problem in 6 ways. Solve for like B, then A, and then C, or solve for B and then C and then A, or any like order that you want to. Mix and match them as you want, but make sure we get the same answer at the end of the day. If you don't get the same answer, please let me know. Okay, so first up the bat in here, let's look for the angle A. So this is the formula that I like copied out from the formula that we had before from the law of cosines. After that, we're gonna plug in a formula, we simplify it, and then we get the like the number in here. And as I told you guys, don't stop in here because this number is only the value of your cosine. Okay, it's only the cosine value. It's not your angle. And if you think about it, this is too small to be an angle, right? Like point something degrees is too small to be an angle. That's like impossible already. I mean, it's possible, but in this scenario, that will be too small. Okay, so what you need to do is that, let me pull it out here, and you have to do cosine inverse of 0.49. Plug it into the calculator and make sure your calculator is in degree mode. After that, it will spit out this number in here. That's the answer for angle A. Okay, and similarly, we're going to do the same thing to find angle B. So I copied the formula right here. After that, I plug in a number, I get a value, and again, I don't stop in here, I don't call it the answer because this value in here is only the cosine value of angle B, right? So let me bring it outside in here. After this point, you have to do cosine inverse 0.73, and whatever the calculator gives you, which is like 42.8 degrees, that would be the answer for angle B, okay? As for the last missing angle, like I said before, don't blindly apply the law of cosines to figure it out. Make sure you know that we have the triangle sum in here, and make sure you apply it in here by using 180 minus angle A and minus angle B. Whatever it is our answer for angle C, okay? So to make it formal, let's put everything into the box and kind of an answer. And here's your try, like here's your turn if you want to try it, and then just like if you have any question, any concern, please let me know, okay? And really quick, in the test, I'm going to ask you guys to draw a triangle diagram like this, label it, and make sure you box the answer like this, just so it's easier for me to grade your answers, okay? Don't just like leave your answer like everywhere. It will be really hard for me to catch it up. And if I cannot see your answer, if I cannot like catch the answer, I'm going to mark it off sometimes because I don't see it, okay? And you might not get the points that you deserve. So make sure you box on the answers. Make sure you make it clear and obvious to me by boxing it or like circling it so that I know that's your final answer, okay? Don't make me guess because chances are I'm going to guess it wrong, and you are the one who suffer from like the point loss, okay? So don't like make me guess. Okay, let's move on to the last like topic of the day, which is to solve for the application in here. So for this topic, the law of cosines in here, we only have like 2 cases. So we only have psi, angle psi, SAS in here, or psi, or SSS in here. And the thing about the application problem or word problems in this section is that you don't have to solve for the triangle completely. That means that you don't have to have all 6 data in here. You only need to solve for whatever the problem asks you, okay? So again, you don't have to solve for the complete triangle. Don't need to get all 6 data. You only need to solve for whatever the question asks you to do, okay? So make sure you read the problem clearly and only answer what they ask you to find. Don't find everything, okay? That's not worth your time. That's not worth your effort at all, okay? So first of all, let's talk about a problem that we have on the left-hand side here, my problem. So let's read it in like 2 seconds or so. And to my habit, I usually like circle all the numbers that I have just to make sure that I'm going to use them all, because chances are you have to like utilize all the numbers that we have from the given problem. If you don't, there might be something wrong already, okay? So again, if you don't use up all the data or like all the numbers that the problem gives you, you might want to go back and double check your solution to make sure that you capture them all, because if you fail to use all of them, chances are your solution is wrong, okay? We also have a diagram in here, so I'm going to go ahead and label it. So the first number in here is 330 miles. It's already labeled for us. The second data is given as 10 degrees in here. It's the angle that's like right there is labeled for us already too. the other two numbers in here is not on the diagram. That means that we have to do something about, right? And you know this one is the rate, okay? Like this one is the rate, and this one is the time. And right off the bat in here, we have two different unit for like one system of time. We have like hour in here and we have minute in here. So there's something wrong with it already, right? Like, so we have to convert it into like one unique system. If you think about it in real life, we usually go with mph, which is miles per hour, right? Like we barely see anyone using mpm for like miles per minute, because minute is like really like small. Like if you think about it, if you want to calculate your rate for the time that you, I don't know, like you go from home to school, and say like in the traffic it takes you like 2 hours to go from home to school, right? You would rather use 2 hours than 120 minutes, because 120 is a bigger number, so chances are you're more likely to mess up with bigger numbers, right? So that's why we're gonna convert everything back into like hours in here, okay? And at this point here, for me, it's an instinct. So whenever you know you have the rate and the time, you have to recall the formula from physics. I know this is like math class, is a trick class, so you're not supposed to like know. I mean, you're not like, the big point here is about math, right? It's not about like all the extra formula from like all the subjects or other levels. But well, just for the sake of like demonstration, I choose this problem because it seems to be a little bit more challenging, right? Like I would refer you guys to go from like harder problems to easier problem than throw it at like and then throwing at you guys at an easier problem right now and having you guys do something like extra hard later. Okay, so that's why I choose this problem. And the formula for the distance formula, let me put it down here. We have distance equals to rate times time. Okay, and the rate in here would be 220, and the time in here would be 15 minutes. But we're not going to multiply them straight because of the time system difference, okay? So before we multiply them, we're going to do converting 15 minutes to hour. And we know that we have 60 minutes in an hour, right? So 15 minutes is like a fourth of an hour. It's like a quarter of an hour, right? So that's why we have the division in here. That's why we have the 60 in here. And for this math in here, if you want, you can plug it into the calculator. But just to clarify down here, 220 is actually 220 divided by 1, right? So don't do something like 220 divided by 220 because that's not right. So when you multiply them, it's going to go like 220 divided by 1 times 15 divided by 60. And the way that we multiply the two fractions is that we're going to multiply it straight. So 220 times 15 on the top, and on the bottom we're going to have 1 times 60, okay? After that, you're doing the multiplication. You're going to get something on the top, you're going to get something on the bottom, you divide them, and then we get the final answer for the distance, which is 55 miles. And the distance in here, what does it mean for the 55 miles, right? It's the distance from Chicago to the plane. So that tells us that the distance in here, it is 55 miles. Okay. And now that we use up all the datas, right, let's talk about the question. The question is asking us for the angle that the pilot should turn to head to Louisville. So let's call this outside angle X in here. But if you notice, the angle X in here is not even a part of our triangle, right? So let me move the 55 over here really quick just so I have space to write out another angle in here. So next to X in here on the inside of the triangle, let's call this angle C because of the position that is like it is in a triangle. So if you want to find X, we have to find C first, right? And then after that, we're going to take 180 minus C, and then that's our X. And why 180? Because if you notice, C and X, they make a straight line. And we know the straight angle is 180. Or if you want to think about it, C and X are supplementary angles, right? So they add up to 180. That means that if we want to find one of them, we have to take 180 minus the other one, okay? So if we want to find angle C, what are the formulas that we can use to find angle C, right? So we know from before that angle C, like cosine of C, it equals to a squared plus b squared minus c squared divided by 2ab. It's going to take some time to memorize the formula, but to me it comes naturally. So I told you before, my trick is that if you look for angle C in here, you have to end up with like little c in here. And what is missing from C, right? We only have 3 letters, by the way, right? Like if it's C, then you know that you have to use A and B in here. And by Pythagorean, that means we're going to have like the plus in between, the sum. And on the bottom, it's going to be like the 2, like not talk about, not mention angles, which are A and B. And because we know 2 angles, that means we have a 2 in here. So to me, the angle will come, the formula will come like really naturally if you know like what a question is like talking about. Okay. And if you notice, if you want to find angle C in here, we have to know all the 3 sides, right? That means you have to know the little b, little a, and little c. We know 1 side, we know 2 sides, but we don't know anything about this side, right? So before we get to know angle C, we have to figure out this side in here. So how can we find a side here? Let's call it like little a in here because of the position that it is in the diagram. How can we find little side A? So recall that we have the formula that a squared equals to b squared plus c squared minus 2bc cosine of a. And again, it takes some time to like remember all the formulas, but at the end of the day, I'm pretty sure you will learn something. Like there will be some part of the formula that you can memorize because there's only like 2 formulas anyways, right? And then like you only need to remember this formula in here because it's like the key point. The other formula, it's just coming from the first formula, so you don't have to like memorize it. If you want, you can just derive it from the first formula. Okay. So how can we find angle little a, right? Little a in here, we're gonna use the formula on the right side in here, and at the end we're gonna take the square of it because of the square in here. That's what I do in here. Let me put an error in here, and after that I plug in a number. And I take the square to make sure that's our a, not our a square. And after that, I'm going to get a number. So this one is our a. Okay, so let me go ahead and replace this one with 276 miles. Okay, now what? Now that we know all the 3 sides in a triangle, we can apply this formula in here to find angle C, right? And make sure after we get the number on the right side, we have to apply the cosine inverse in here to get the angle C like before. That's what I do in here. So I do 2 steps at one. I do cosine inverse in the calculator, and I input like all the formula on the right side in here. But if I were you, I would take the time. I would like make it slow because if you, I kept like running out of space in here. That's why I do 2 steps at one. But for you guys, make sure you do the right side first, and after that, you do the cosine inverse secondly, okay? Don't put everything into the calculator at once. Sometimes it works, sometimes it doesn't because of the parentheses. The calculator can be really sensitive with the parentheses, okay? So if you mess up like any of the parentheses in here, the calculator will give you the wrong answer, okay? So that's what I'm saying. If you have time, if you have space, I mean, of course you have space, right? Make sure you do step by step, right? Like make sure you do the right hand side first, and after that, apply the cosine inverse secondly to find out the angle. Okay? Don't be too rash like me. Don't just put everything into like one step like me. It might cause you some trouble sometimes. Okay? Now that we know angle C, which is like 168, and the question is asking us to find x, right? What can we do is that we're going to have x equals to 180 minus c. And c in here, we just figured out that c equals to 168. So we do the math, we plug into the calculator, and we have 12 as our final answer. So make sure you put in the final like a complete sentence in the test and the quiz, just so it's easier for me to grade, okay? And here's your problem. If you want, give it another try just to make sure like you got it clear. This one is harder a little bit, but if you want to try it, let me know how it works, and then we can talk about like how to unsolve the problem that you might have. Okay. Anyway, just let me know. And onto the last page in here of today. I mean, this one is like the formula. These are the fun formulas that I scrape out from the textbook. I'm not gonna test you on this, so let me just put like test in here and like scratch it out. I will not test you on this page in here, like all these formulas in here. I'm not gonna test you on this one. But just in case you are a STEM major or you're a math major in general, you need to go on to like calculus classes in here. I would recommend you like have a good reading, especially on the last formula in here because it's really useful. As you can see, the format is like similar to the law of sine, right? But we also have like the common ratio in here, which is like another part. But if you want, you can read the derivation of this formula in here. It's really powerful. It's useful in the future if you want to build a house or like build a bridge or something fancy like that. But in this class, if you're not a STEM major, you don't have to care about this formula too much, okay? Just read it for fun. It's from the textbook, okay? And the first two formulas in here, if you notice, these are the half angle formula that we learned from 8.6. But the right hand side here is not exactly what we learned from 8.6. We use something we call like the half perimeter in here. And we're going to talk more in depth about the half perimeter in 9.2. I mean 9.4. There we go, 9.4. You guys can hear it again on 9.4, the area of a triangle. But again, I'm not going to test you on any of these formula because personally, I like all these formulas because they are like really interesting and then they have like different use. But for this class, it will be too much if I'm asking you to like remember them all. So I'm not going to ask you to remember all of them. But these have like good application. And if you go further into like calculus classes or like STEM major, you might need to like read these just so you can get more prepared for yourself for like the next material, the new material in those classes. Okay. So anyways, thank you for your listening and have a great day.